How to understand mathematical structures in nature. Imagine walking through a forest and noticing how the branches spread out like a network or how seashells spiral perfectly. These natural patterns are not random. They follow specific mathematical rules. When you start observing closely, you see that nature is full of shapes and arrangements that repeat and grow in predictable ways. Recognizing these patterns helps us understand how nature uses numbers and shapes to solve problems like growth, packing, and movement. One of the most common patterns is symmetry. Think about flowers, butterflies, or crystals. They all have balanced parts that mirror each other. Symmetry makes structures stable and efficient. Then there are spirals, which you see in sunflower seeds, pine cones, and even hurricanes. These spirals often follow the Fibonacci sequence, where each number is the sum of the two before it. This sequence helps plants optimize space and sunlight by arranging leaves or seeds in a way that maximizes exposure. Fractals are another fascinating structure. They are shapes that look similar at different sizes. For example, a fern leaf or a snowflake repeats its pattern no matter how much you zoom in. Fractals are useful for explaining complex natural forms that seem irregular but follow simple rules. Hexagonal patterns are also everywhere, especially in structures that need to be strong and efficient. The honeycomb built by bees is a perfect example, using hexagons because they use the least material to hold the most honey. Insects' eyes, basalt rock formations, and reptile scales also show hexagonal patterns. Branching systems are common in nature too. Think of trees, rivers, and blood vessels. They branch out to distribute resources efficiently. Waves and ripples in water, sand dunes, and coastlines follow wave-like mathematical patterns. Tessellations, which are repeated shapes that fit together without gaps, appear in fish scales and honeycombs. To understand these structures, look at nature carefully and try to spot these patterns. Learning about the math behind them, like sequences, shapes, and scaling, shows how nature uses numbers and geometry to grow, pack, and move. Recognizing these patterns connects math to real life, making the world around us more interesting. You can even use this knowledge to improve design and engineering, like creating fractal antennas or hexagonal tiles for stronger materials. In short, understanding mathematical structures in nature means noticing patterns like symmetry, spirals based on the Fibonacci sequence, self-similar fractals, hexagonal packing, and branching networks. These patterns reveal how numbers and shapes shape the natural world in both how it looks and how it functions.